Bridge is 7.2, simplifying radical expressions. All right. So basically, when we're simplifying these sorts of things, we're taking advantage of the fact that the nth root of x times y is equal to the nth root of x times the nth root of y, and occasionally you can simplify one of those. Or the nth root of x over y is equal to the nth root of x over the nth root of y. So, we already looked at this when we worked on simplifying square roots. So let's see what we can do. So let's say I want to do the square root of 75. Well, I can observe that 75 is 25 times 3. So this would be the square root of 25 times the square root of 3. And the square root of 25 is 5, so this would be 5 square roots of 3. Now, if I didn't know that, what I could do is I could say, okay, 75, and I could make this prime factor tree. Remember, prime numbers are numbers that are only divisible by 1 in themselves, so like 2, 3, 5, 7, 11, 13, those are all prime numbers. 2 doesn't go into 75, but 3 does 25 times, and then 25 is 5 times 5, and for a square root, you're going to circle pairs because that makes a perfect square that you can simplify. And then that 5 goes on the outside, and then that 3 goes on the inside. I can get this magic pen working. So anyway, this 5 comes here, and that leftover 3 goes there. So let's say I wanted to do the square root of 72. All right, well, 2 goes into 72 36 times. 36 is 2 and 18, 2 and 9, and 3 and 3. You want to make sure you do all your 2's first, because if you don't do all your 2's first, then it's like, okay, I got a 2 here, and then I got a 2 somewhere over here, and so then those go together. It makes a big mess. So you want to make sure you've got all your 2's collected together so that you can find your pairs a little bit easier. So there's a pair of 2's, there's a pair of 3's. 2 times 3 is 6. So there's a 6, and then there's just a 2 left over. So then that's the square root of 2. By the way, had there not been any leftovers, then the square root part wouldn't even be there. So like, for instance, if it had just been the square root of 36, you'd have a set of 2's and a set of 3's, and it would just be 6. It wouldn't be 6 square roots of anything. It would just be 6. All right. So how about the square root of 162? So 162 would be 2 and 81. 81 is no longer divisible by 2, but it is divisible by 3. So you get a set of 3's and another set of 3's. 3 times 3 is 9, so that's 9 square roots of 2. And by the way, had you had multiple things left over, you would just multiply them together. So like if I had had this 2 and another 5, then this piece right here, if I had had a 2 left over and a 5 left over, would have been the square root of 10. Because 2 times 5 is 10. All right. So then we need to be able to do this with variables as well. And we're going to assume that these variables are positive so that we don't have to mess with absolute value or anything. But basically, I've got the square root of x squared. Well, x squared is this, and since it's a square root, I want to circle pairs. Well, the square root of x squared is just x. Well, what if I want to do the square root of x cubed? Well, x cubed is this. I can circle a pair. So then I've got an x and a square root of x. This x comes here, and the x that's left over goes there. So for instance, if I had the square root of 25x squared, first of all, the square root of 25 is 5, and the square root of x squared is x. The square root of 12x cubed, so I've got 12, which is 2 and 6, and then 2 and 3. So I've got a set of 2's there. And then notice I've still got this already worked out right here. So I'm going to have a 2 and an x for the outside. And then a square root, and then a 3 and an x for the inside. So just to kind of illustrate, there's your 2 times x, and there's your 3 times x. Square root of 144x to the fourth. Make your tree. Guess I need to scroll some more. Two, and 3. So that would make a 12. And then x to the fourth. And if I'm taking a square root, I got a set and a set. X times x is x squared. Because I've got 2 sets of x multiplied together. Okay. Square root of 72x cubed y. Well, 72 is 2 and 36, 2 and 18, 2 and 9, and, well, we already did 72, well, I've pretty much got this done already. So once again, this is 6 square roots of 2. Your x cubed, so you got an x with an x left over, and then your y, there's not much to do with that. So I've got the 6 and the x, so this would be 6x square root of 2x, y. Because that y has got to stay in there. Well, that's basically all there is to square roots. So let's see what we can do with other roots. All right. Let's say I want to do the cube root of 40. Well, I break this down the same exact way. 40 is 2 and 20, 2 and 10, 2 and 5. But this time, instead of circling pairs like I did for a square root, since this is a cube root, I'm going to circle triples because that makes a perfect cube. Because earlier we were pulling out perfect squares, so 2 of the same number makes a perfect square, 3 of the same number makes a perfect cube. So that 2 would go on the outside, and 5 would be left over on the inside, so this would be 2 cube roots of 5. Well, what if we do the cube root of 80? Well, what I can do is I can piggyback off this guy, because 80 is 2 times 40. So notice this time I've got a 2 for the outside, and I've got a 2 and a 5 left over right here and right here. So those multiply and give me a 10. If I've got the 4th root of x to the 5th power, x to the 5th power looks like this. I'm taking a 4th root. I'm going to have a set of 4. So that's x 4th roots of x. Where the set of x's gives me the x on the outside, and the leftover x is the x on the inside. All right. The 5th root of 486, x to the 7th. (243) isn't divisible by 2, but it is divisible by 3. Since it's a 5th root, I want to set a 5. X to the 7th. 1, 2, 3, 4, 5, 6, 7. That's a 5th root, so I'm going to want that many. So I'm going to have a 3x for the outside. I'm going to have a 5th root. I've got a 2 left over. And if you look at these x's right here, x times x is x squared. All right, last one. Cube root of 128 x cubed y to the 5th. Let's quickly get this churned out. This tree is somewhat lengthy. So anyway, since we're doing the cube root, we circle triples. So that would be a set of 2's. And another set of 2's with a 2 left over. Notice that x cubed would be x times x times x.
Are you talking to us?
No.
Oh, the Bridges video. Sorry. I was really paying attention too.
Shut up, Tyke.
Sorry.
All right. So anyway, so if I combine all the sets together, I get 4xy cube roots of 2y squared. There are no x's left over, so there are no x's that go underneath the radical. And just to make sure everybody's on the same page, this 2 and this 2 multiply to give you 4. There's your x. There's your y. And then those 2 y's give you your y squared. And that 2 is that 2 right there. All right then. The assignment that goes with this section is on page 462. And on page 462, you will do 2 through 10 even and 24 to 34 even. That is all.